Hello, everyone. I just wanted to make a few brief remarks about what we're doing this week, what we're beginning to do this week, and that is formal logic. Uh, it can actually be interesting and it can help. What is formal logic? It's as opposed to informal logic, it's looking at the forms of statements and the forms of arguments with the ultimate goal of, as the author says, formulating a precise notion of validity and invalidity. But what are we really doing? Formal logic is symbolic logic. If I say Jane is eating a burger, I've said Jane is eating a burger. I can represent that statement, and it is a statement. Let's just say by any letter, any symbol. Let's just say J. So in formal logic, instead of saying Jane is eating a burger, I just say J. If I say Jane is eating a burger and Ken is sleeping, I've made a different sort of statement. This is a conjunction. And all that means is that it has an and. I've really said two things. I've said that Jane is eating a burger, and I've said that Ken is sleeping. And I can represent that symbolically by saying, let's say, J and K. So let's take a look at that. What am I saying when I say J and K? I've said that J is true. I've made an assertion that J is true. And I've made an assertion that K is true. That is, I've said that two things are true. Jane is eating a burger, and Ken is sleeping. So, what we're interested in are the truth conditions of a conjunction, a statement like this. Um, what if J is false? That is, Jane is not actually eating a burger. Well, then the statement that Jane is eating a burger and Ken is sleeping is false because what I've said is that they're both true. So, pretty quickly, I come to realize about conjunctions that pretty simple. Right? A conjunction is true only when all of its elements, all of its atomic propositions, and an atomic proposition is just a proposition that doesn't have an and or an or an if in it, the truth functional connectives. And it's pretty simple, right? And that's where the truth table comes in. I can pretty easily lay out the conditions under which a conjunction is true, and it's only when all of its conjuncts, all of its elements are true. Now let's contrast that with a disjunction. Uh, Bill is a Marine, or Sally likes the Eagles. I've used a different truth functional connective there, an or instead of an and. What are the truth conditions of a statement like this? Well, this is where disjunction can be a little bit counterintuitive. One of the things to remember is that in logic, formal logic, the or is always an inclusive or. The exclusive or, which basically says that one or the other is true but not both, is different. It's one of the things you got to get used to when you're being introduced to formal logic. So I said that Bill is a Marine, or Sally likes the Eagles. What if one is true? B. Let's say B, we're saying B or S. What if B is true, but S is false? Then I look at my disjunction, and what I've said is that Bill is a Marine is true, or Sally likes the Eagles is true. So say that only one of them, B, is true. What does that? And the other is false. What does that say about the whole statement, the whole disjunctive statement? Bill is a Marine or Sally likes the Eagles. Well, what it means is that it's true, because I've said Bill is a Marine is true, or Sally likes the Eagles is true. So if either one of them is true, then the statement as a whole is true. What if B is true, or and S is true? Well, since all I've asserted in my disjunction is that at least one of these things is true, then if both of them is true, then at least one of them is true. So if B is true and S is true, then the statement as a whole is true. Now, this is the inclusive or. The exclusive or is something that we can derive, and he does, I think, in section 2.5. So, really, what you're doing here, this is it's just what we're doing in looking at symbolic logic is basically two things. Um, Practicing how to translate ordinary sentences into symbolic logic, and it's just a method, right? Um, how about this? It is not the case that Jim is a priest and Bill is a postman. You know you're getting somewhere when you say, okay, I know what that means. Basically, not. It's not the case that J is true and B is true. Right? You would have the tilde instead of not. I don't know how to make it on the computer. So what you've said is not the case that both Jim is a priest and Bill is a postman. So it's not the case that J is true and B is true. That's all we're doing here in the first part of it is just practicing how to translate ordinary English sentences into symbolic logic, into this particular form. Um, I don't know. How do we do that? Well, I mean, using the parentheses, Jane is a cop, J, and Sally is a teacher, S, and well, I mean, actually, you don't need the parentheses. Actually, Jane is a cop and Sally is a teacher, and it is not the case that Bill doesn't like milk, but Bill doesn't like milk. It's not the case that Bill likes milk. I might have even messed up here. It really doesn't matter. You don't have to be perfect. This is not a class where you'll be really tested rigorously in your. It's usually giving you the idea because it's a quick introduction, and it's not for its own sake. Right? The idea is that we're putting these things into symbolic terms for what reason? We're doing all this to get a rigorous and precise idea of validity. Being introduced to the idea that validity, that is, an argument whose reasoning is valid, is something that we can determine not just informally, the old informal test of validity, but sometimes at least with deductive arguments, formally, precisely. And perhaps I'll make a video on that.